Hello, I'm Shan and welcome to the video of my final year project, Knowledge Graph Construction from Text with Co-Reference Resolution. The motivation behind this project is to take an article, then transform it into a knowledge graph which provides a concise representation of the article. Before we proceed further, allow me to introduce a linguistic concept called co-referencing. In written or spoken English, an entity is usually mentioned by the proper noun form once, and all other mentions will take on other forms such as pronoun or adjective noun. The two most common type of co-referencing is anaphoric and cataphoric referencing. First, let's take a look at an anaphoric reference example. In this example, a pronoun takes the place of John after its first mention. Now contrastingly, in cataphoric referencing, the entity is first mentioned as a pronoun before the proper noun is introduced. Undeniably, usage of co-referential term eases communication. However, in information extraction, it could be a hindrance. Moving on, the information extraction process can be done using tools such as Open Information Extraction or OpenIE in short. OpenIE extracts semantic triples within a sentence. Each semantic triple is made up of subject, relation, and object, which makes them suitable for knowledge graph construction. That said, in the example sentence shown, we have the subject in red, the relation underlined, and the object in green. If you build a knowledge graph out of the four relations extracted, she will be seen as a single entity whom participated in dance competition and owns a dance studio, which is not only factually inaccurate but also ambiguous. By looking at the knowledge graph alone, we are not able to tell who is she. What I aim to achieve out of this project is to resolve these ambiguous entities into their appropriate entity. In order for that to happen, we must first identify all co-referential terms. This task is known as co-reference resolution. Using an open source co-reference resolution tool, we first identify the co-referential mentions, then group them into co-referential clusters. So from this excerpt, 4 clusters were constructed. The next task on hand is to select one term from each cluster that sufficiently represents the entire cluster. There were several past works that attempted to identify this suitable representative term. Firstly, one of the works considered picking the antecedent in every case. In this approach, it is assumed that all co-references are anaphoric references. Thus, all cataphoric references would have their representative term wrongly selected. Another work selects the longest span as the representative term for each cluster. While this method is not limited to anaphoric references, length is not the best measure for representativeness of a term. In this project, a new method of selecting representative term is introduced. The underlying model of this method is a binary classifier. 2,630 terms were labeled whether they are representative of a cluster or not. From this labeled data, a binary classifier is trained. The final output of the binary classifier is then processed to obtain the desired representative term for each cluster. Allow me to walk you through the term selection process. We first select a cluster we would like to process. Each term of the cluster will then be fed through the binary classifier. The role of the binary classifier is to answer the question, is this term a representative term of the cluster? The classifier will produce 2 probability scores, one indicating how likely the term is representative of the cluster and the other being otherwise. From here, we cannot make a decision whether a term is representative of a cluster by simply taking the outcome with a higher probability, because it is possible that more than one term within a cluster have the same outcome. So instead, for each cluster, we put together the probability of yes for all the terms and identify the term which is more likely to be representative over the others. In this example, the term Singapore will have been deemed more representative than the term the Republic. Using this approach, we were able to identify the representative term with much greater accuracy. The next step of this process is to extract the semantic triple from the article using an OpenIE system. Some of the relations extracted by OpenIE 4 from this short excerpt is as shown. Feel free to pause the video if you would like to look through the article and the semantic triples generated. Now, piecing everything together, we first identify all co-referential mention within the subject and object of the semantic triple. After all the co-referential terms are identified, they are substituted with the representative term of their respective clusters. Once the substitution is complete, the amended semantic triple would be forwarded to a graphing tool for a knowledge graph construction. In this project, Neo4j graph database was used to demonstrate the knowledge graphs.